All right, everyone, let's get started. My name is Maher. Thanks for joining today. And let's go ahead and talk about the AP Statistics test and what to expect. So let me go ahead and share my screen and we could get started. Okay. All right. So can you guys hear me well?
Yes.
Okay, thank you. Okay, so the first thing we want to go over is what we have. We've got two questions. One's 25 minutes, the other's 15. The first one's worth slightly more of your grade, and they're definitely going to cover at least 2 units each from these units right here. So we're definitely going to have one variable data, two variable. We're going to have to figure out how to collect it, good research methods. Probability and random variables we'll talk about. The sampling distributions, this is where most students really don't understand the concept, so I'll make sure we get into that. And then the inferences, the tests, I'm gonna, if you guys don't already know, teach you how to use your calculator to really make those kind of problems quite simple. Now, there will not be any chi-squared, and there will not be any inference for slopes or regression for that matter. So let's go, well, there will be certain regression, but you will not be doing tests of regression lines. So that you definitely didn't get to that yet. So, excuse me? Okay, so we have the formula sheets. We want to keep them in handy. Descriptive statistics. We'll come to a few of these, but our calculator will allow us to do a lot of them. What kind of calculators do you guys have, by the way? So I kind of know what you're working with. Hopefully you guys got
TI-83.
perfect. So definitely be able.
TI-84.
Awesome. Okay, as long as it's TI-83 or above, we got all the functions that we would need. Let's go ahead and try the first FRQ. So I'm going to give you guys a little bit of time to work on them before we talk through them. So go ahead and please pull out a pen and paper. We'll go for the first one. The sizes in square feet of the 20 rooms in a student residence hall at a certain university are summarized in the following histogram. Okay. And here it is. Based on the histogram, write a few sentences describing the distribution of room size in the residence hall. Okay, take a couple minutes. Also, if you'd like to type your answers into chat, I could talk about them too. So it's up to you guys. Okay, so you guys want to give, anyone want to give that a shot? This distribution of room size. I do want you to be quite thorough and hit a few key points to get full credit. Anyone want to give that a shot? What were some of the obvious things that we could see? Well, we got what's called a bimodal distribution. So they want you to say that in some way, shape, or form. 2 peaks, 2 clusters. But definitely have to mention that. They want you to mention the average, which would definitely be somewhere between 200 and 300. Kind of want you to mention the spread, and a little bit of the context. So anytime they ask you to describe a histogram, they want the shape, the center, the spread, and the context that you are dealing with. So make sure you always describe those few things anytime you have a distribution, and they're definitely going to ask you to describe a couple. So shape, center, spread, and context. If you hit only a couple of these and say it's bimodal or center is 200, they're only gonna give you partial credit. So you need to hit all four anytime we're dealing with the distribution. So you guys really know how to focus your answers. Any questions on A?
No.
So B, summary statistics for the sizes are given in the following table. Okay, mean, standard deviation, and the 5-number summary. Determine whether there are potential outliers in the data, then use the following grid to sketch a box plot of room size. Go ahead and take a minute there. So in order to determine outliers, do you guys remember the rule of thumb that you want to use for that? It's almost like two formulas. And we can say that an outlier is going to be, so an outlier will definitely be bigger than 1.5 times the interquartile range plus the third quartile, or an outlier will be smaller than the first quartile minus 1.5 times IQR. And that's where, if we're drawing a box plot, that's where our kind of box would, our whiskers would end. And then we could put dots outside of them if there are any outliers. So we could go ahead and calculate that first. How do we calculate the IQR?
Would you subtract the Q3 and minus Q1, right?
Exactly, the value of Q3 minus Q1. So a lot of calculators, use them every time you can. 292 minus 174, in a quartile range of 118. Therefore, the outlier will have to be, let's do 1.5 times 118, plus the third quartile, plus 292. So the outliers on the upper end must be bigger than 469. Do we have any outliers on that end?
No.
No, the max is 315, so definitely not this time. And let's check the lower bound. We got 174 minus 1.5 times that interquartile range of 118. And that's -3, definitely not. So if we show the fences, that'd be perfect. So the fences are, well, -3 way out there and 469. So then we want to sketch a box plot. So how do we sketch a box plot? What do
You,
go
could
ahead.
you use the values given for example, you'd use Q1, Q3 for the inner box, and then like the actual middle would be your median, and then your ends would be your max and min.
Perfect. Well, yes, in this case, absolutely. All right, so from Q1, 174, somewhere right here, 292, with the median right here, 253. Going out to 315 and 134. Questions on the box plot?
Do you think they're gonna ask us to create a box plot for the exam?
They definitely could, yes. Questions on how you would do it if you needed it, though. You definitely would need that 5-number summary in order to even try it. Or enough data to create your own 5-number summary. Okay, what characteristic of the shape of the distribution of room size is apparent from the histogram, but not from the box plot? So go ahead, take a second. Anyone who has a thought, give it a try. Okay, well, from a box plot, we definitely can see a spread, but we can't see any sort of bimodal or trimodal distributions. It kind of all gets blended in. So the score that they're going in for there is basically just to explain that you'll never be able to see a bimodal distribution with a box plot alone. The bimodal distribution does make that interquartile range quite drastically big, which is why we definitely don't see any outliers here. However, if we were to look at these two, let's say it's bimodal, most of the time, if anything's bimodal, there's a clear reasoning for it. Males might be taller than females or a certain thing. So you have half the population with a certain average and the other half with a certain average, but then they blend together and you get the bimodal peak. But if you were to take their populations individually, that variance would go down quite drastically. Each box plot would probably be very small compared to this one. So just conceptually, bimodal distributions just indicate that you probably have two different populations, or your population has two different groups broken apart by one variable that causes a completely different change in their distribution. So that's just a little extra conceptual in case they wanted to throw that in there. Any questions with that one?
So for questions like that, we would just be like giving them like context answers and explaining like the difference between the histograms and the box plots and like what they show.
Absolutely. You need the context. It's not enough to just say histogram and bimodal, you're not going to find them. You need to say what it says about room size. So perfect. Just make sure you sneak in the context every time you answer any question. Hit them with a few statistical ideas they want, and that's how you make sure they're not going to be able to sneak any points away from you. So yeah, good question. In fact, you probably get only half credit if you were just to say bimodal, and you wouldn't be able to see that in a box plot. But you literally, just by adding the words room size or square feet or then you get your extra points. So if no other questions, I think we're ready for problem 2. Okay, so this one, I'm going to give you like 3-4 minutes to read and give a shot, and then we'll talk about that. Okay, anyone have the treatments?
Wouldn't the treatments just be the different concentrations?
Exactly. So treatments, the 4 different concentrations, then go ahead and list all 4 of them and full points. Whenever anyone's ready for experimental units, go for that. So anyone know that what experimental units really are? That would be basically the subjects of the experiment. So here, what would the subjects be?
Would it be the insects?
Are we basically getting data for each insect?
It would be the individual containers.
The individual containers with the equal number of insects. So that's what we'd actually be getting data for. So good, good one there. Questions on that distinction, because that one will definitely give you 0 points for the first answer. So that's what they kind of wanted a lot of students to say there. But definitely the thing that's going to be measured are the containers. And each container will be measured for blank. And then we could say that. What is the response variable? What's another name for a response variable?
dependent variable.
And what is the dependent variable in this situation?
Would it be the amount of insects left alive after the spray after 1 week?
Perfect. Full points there. Okay. All right. Now, does this experiment have a control group? And explain.
The 0 milliliter is the control group.
0, 1 would be the control group. Perfect. Anytime 0 is an option, that's perfect control. If you're comparing two other ones, let's say just 2.5 and 3.75, we don't really have a control there, unless 2.5 was the baseline and everyone uses it. But yeah, we wouldn't really have a control unless it's 0. So that's a good one. And why is 0 important? You have to say like a quick sentence on that. What does doing 0 allow you to kind of claim later on? Well, using 0 allows you to claim that clearly this, of the lack of this would have a certain level, but we could tell that this independent variable is definitely causing it by manipulating it and just adding a condition that's greater than 0. So we could say from 0 to another one that this is truly the difference between them. So that really helps that out. And describe how the treatments can be randomly assigned to the experimental units so that each treatment has the same number of units. Okay. Anytime they want randomly assigning, you could kind of get creative with it, but the best, easiest thing is a random number generator. So you could kind of label each container with the integer from 1 to 20 and randomly create a plan where I'm going to print out a random generated list of numbers and I'm going to do what comes first. So if I see the number 1, I'm going to do that. If I see, well, the number 2 or number 18 first, so you could kind of use that random number generator. And had you assigned them a number originally, and then you allow the random number generator to pick the order, and that order will allow them to get split into the groups. So random assigning, definitely that would be the easiest way to state that. Any questions on that one?
How do you do that in the calculator, the random number generator?
Oh, no, you don't. You just explain it. That's how you would do it. They'll never ask you to do the random assignment yourself. Yes. Yeah, so good question, but we wouldn't need to worry about that.
So that's the easiest treatment that we can do, or like would be the random number generator.
Yes. That's the one that they kind of give you full points for really quickly. Other ways that they kind of analyze a little bit more carefully and try to look for problems with it to make sure, oh, that makes it not random. But if you use a computerized random number generator, you can't really go wrong there. So let's go on to this next one. Medical researchers surveyed a large group of men and women about whether they take medicine as prescribed. The responses were categorized as never, sometimes, or always. The relative frequency of each category is shown in the table. A, one person from those surveys will be selected at random. What is the probability that the person selected will be someone whose response is never and who is a woman? Take a minute, let me know what you think the answer is and how you calculate it. So response is never and who is a woman. Well, if we want never and woman, all of the probabilities add up to 1. So if we randomly selected one person from the population, never and woman, just this number right here. Any questions on that one? Okay. What about the probability that the person selected will be someone whose response is never or a woman? How do you do that?
Would you add up 0.12 plus 0.53?
You would, but what else would you need to do?
You'd have to subtract,
subtract.
0.
Hmm?
You'd have to subtract 0.0636 because you might be double counting it.
Exactly. So the probability of any A or B equals probability of A plus the probability of B minus the probability that they occur together. And sometimes this doesn't happen if the events are mutually exclusive. If they're mutually exclusive, you cannot have A and B at the same time. So name 2 things that are mutually exclusive here. Well, so no one can be both in the male category and female category here. You couldn't have, so those are mutually exclusive, and your response is mutually exclusive. You either answered never, or sometimes, or always. You can't have those be ands. You can always only have the ands going the other ways. So just to kind of throw some other words that they probably are going to get to, if not this one on your FRQs. So that would, yeah, exactly. 0.12 though, plus 0.53 minus the probability that they occur together and they can occur together. And that would be it. What is the probability that the person selected will be someone whose response is never, given that the person is a woman? Okay, so we want probability of never, and that's a sign for given that the person is a woman. Any ideas for that?
Would it be 0.0636 divided by 0.53?
Exactly. So the probability of never and woman over the probability of woman. So anytime you have a given one, so I'll write the more general one right here. Probability of A given B, that's going to be the probability that A and B occur. But it's anything that's the given, that's the denominator. probability of B. So here the denominator would be probability of woman. And the top would be probability of never and woman. So perfect. Would go ahead and thoroughly write the notation like this too, and not just kind of put a couple numbers on there and say that. So that could get you partial credit. So you definitely want to be thorough in what you're explaining. This would be the best one for that, the context that we're dealing with. Write it like this, please. Questions on how you want to do that? Okay. Next one's a little tricky. I'm gonna give you guys a couple minutes for that one for sure. For the people surveyed, are the events of being a person whose response is never and being a woman independent? And justify your answer. Yeah. Will anyone have the conceptual idea of how to determine independence from a two-way table? What are we looking for? We're looking for if probability of A given B equals the probability of A. If they are independent, then that, given that they are male, shouldn't have anything to do with their answer. So if they are independent, the probability of A given B is just going to be the probability of A. So then they are independent. Now, P of A given B are never given a woman. When you said 0.0636 over 0.53, let's plug that in. 0.0636 divided by 0.53. I get 0.12. What's the probability of never anyways? 12. So exactly 0.12 of all women answered never, but so did 0.12 of all total. So that equals that. They are independent. And that's literally all you need to state. You don't need to, for these type of problems, you answer that, you show that calculation, and then you can claim they are or they are not. They don't need anything else there. That's your justification.
Couldn't you take the probability that it's probability of never times the probability of woman, see if it's equal to the probability of never and woman? Is that another way to do it?
Probability of never.
So like 0.12 times 0.53, and since that equals to 0.0636.
Yes, that's kind of like working it backwards. But I'd probably say this is, that's like the more textbook definition. I think they'd give you your points, but if you could go with this, I'd probably recommend that. But since you did describe it, and if you could justify it, they'd have to give you your points, I'd say. Doing that in a large population, the probability that a person will always take medicine as prescribed is 0.54. If 5 people are selected at random from the population, what is the probability that at least 4 of the people selected will always take medicine as prescribed? Support your answer. When calculating probability, the first and foremost question you want to ask yourself is probably what? Anyone want to take a stab at that? My question is, how is this distributed? What type of distribution can be created out of basically this scenario that we're dealing with? We have a normal distribution there. Definitely not normal, since it would have to have a mean centered at something. This is probabilities. This is a little bit different, but here, this is a few things we want to know. They have a probability that they're going to be prescribed, or that they're always going to take the medicine, is 0.54. So they're saying there is a probability. And they're saying they're going to pick 5 people. So we have n equals 5. And they want to know what happens if we get greater than, what's the probability of getting greater than 4? Now, if you're going to have 5 people selected at random, that's really important. They're saying they're choosing a fixed number. So we have a fixed number of observations, or whatever the case is. And then the probability stays the same. The probability of successive attempts stays the same. So they're saying it's 0.54 for everyone. It is 0.54. So it's in a large population. So the large population allows us to do some other thing and say, okay, these trials are independent from each other. Independent from each other. So we have independent trials. We have a fixed number of trials. The probability of success remains the same. Remains the same for all trials. And there's only 2 outcomes, success or failure. Either they always take it or they don't. I know sometimes and never is the answers there, but we could pretend that it's either success or failure, because we don't care if they're not always, they're not part of our answers here. So 2 mutually exclusive outcomes. That's the 4th requirement. Now, these are requirements for what? So 1, 2, 3, 4. These 4 requirements are the requirements for a binomial distribution. If you have a fixed number of trials where you either have 2 mutually exclusive outcomes, success or failure, and the probability of success remains the same for all trials, pretty much due to the fact that the trials are independent from each other, We have a binomial distribution. So you have to read that in context and realize, okay, fine, fixed number, fixed probability, success or failure, either they do or they don't, and independent, large population. So they kind of explained everything we needed to say, yes, this is a binomial distribution. Any questions with that?
No.
Knowing the binomial distribution is half the battle. Now the other half is using it to find the probabilities that you're asked. How might you do that?
Would you use binomial CDF?
You could use binomial CDF, absolutely. Binomial PDF, add a couple of them. Are you? How would you put that into your calculator? Since everyone here does have that, let's see if we. So plug it into your calculator. Let's see if we do get the correct probability.
Is there any way to do it without putting it in your calculator?
Do you not have a calculator?
Well, like, I don't know. Are you allowed to use it on the AP exam? Because my instructor just like prefers me not using a calculator.
Oh. Absolutely, you can. They are going to grade the work the same, whether you handwrite it and take forever to do it, or you literally just say binomial CDF with this sample size and this probability. So you could literally write down, but you have to write it on the test, write down the function you used and everything that you inserted into the function itself. And that's always, always, always enough to get the credit. So just to make it easier on you, I'd recommend if you know how to use a calculator, go for it. So if you needed it without that calculator function, yes, there is a, and it's on our formula sheet. So since your screen shared, let me go back and see the formula sheets. Here's some of the probability ones we were talking about. No chi-squared. Let's see. Oh yeah, here it is. If X has a binomial distribution with parameters N and P, then here's how we would do it. And we'd have to basically add all of them up. So if we want 4 and 5, we'd have to, let me snip that, take that over. So in order to do this, we'd have to say, all right, we're gonna do 4 success, but then it says probability of at least 4. So then we're gonna have to do a second calculation for 5. And it's gonna end up, since I have that right here, it's gonna end up looking exactly like this. So here's the probability of 4 without, that CDF. If you needed it, this function, this formula is on your, formula sheet, and you could plug into it right away. But then this is easy enough because there's only 2 things that you have to do it for. But if there's 3, 4 plus things you want to do it for, binomial CDF will save your life. So instead of doing several calculations, because sometimes 4 or 5 can, if you have 4 or 5 of them, there's lots of room for error. Because remember, this thing right here in of itself is difficult, this 5/4 combination. So it might look easy, but it's not that nice to do by hand. But if you can do it either this way or with the normal CDF, let's try to get that probability and see if we all get to the same way no matter what we want to do. So anyone, so take a second, let me know what probabilities you get when you get the calculations.
So what's the difference again between using the binomial PDF versus CDF?
Binomial will only give you an exact. The the binomial PDF says if you plug in 4 into it, what is the probability that I will get exactly 4? So the way you could do this problem with binomial PDF is doing a PDF for 4 and adding a PDF for 5. CDF tells you the probability, depending on your calculator version, of obtaining that value or less. So if it was like, if you wanted to know less than 4, then we could plug in 3 into a binomial CDF and it will give us that probability. Or if it said 4 or less, instead of adding 0, 1, 2, 3, and 4, we'll do a binomial CDF of 4. But sometimes you have to go one underneath it because it will include the value, the probability of the value you have. So if you want less than 4, you do the binomial CDF of 3. Does that make sense?
So it only calculates if it's like less than.
That value or less. So if you plugged in CDF of 4, it'd be, that's a probability of 4, 3, 2, 1, or 0. So in order to use CDF here, you'd probably have to use 1 minus the binomial CDF of 3. So you could subtract 3, 2, 1, and 0 from there. Or you could do the binomial PDF of 4 plus the binomial PDF of 5. So literally you could get points for, so showing this one is how you get points, or by showing 1 minus binom CDF of n equals 5, p equals 0.54, x equals 3. Or you could write binomial PDF of n equals 5, p equals 0.54, x equals 4, plus same binomial PDF for 5, and you avoid doing any other calculation. So either or. I know if a teacher hasn't really taught a calculator method the whole time, they're kind of going to want to keep shy away from that. But if you have been, I'd say go for it. So either way, but what is your guys' answer here?
I got 0.280600848. But do you want me to round to 3 places or?
It actually sounds wrong. So what did you put into your calculator?
I did binomial CDF PDF plus binomial PDF of 5. So I'll just go to where I was, and so what I did was use binomial PDF, and I entered in 4.45 and then 4 for my x value.
You need 5 because there's a
Okay.
number of trials.
Mm-hmm.
5 trials.
Okay.
And then 4 successes. And then binomial PDF for 5 trials, 5 successes.
Okay. Okay.
And then
I got 0.12.
0.12 is also off.
0.1217.
I got 0.241.
That would be the answer right there, 0.241. So let's all make sure, ask me questions if you're having trouble, and I could definitely explain what went wrong. So what did you plug in if you didn't get the right answer?
Wait, so should we be using binomial PDF instead of CDF for this one?
It's either or. It doesn't matter actually one bit. It's they're both just as easy because you could do 2 PDFs or one minus a CDF. Certain times, if you might have to do several PDFs, definitely do CDF. But in this case, it's not much harder either way. You're free to go either option. So, but then let's work on binomial PDF. Let's make sure we get it right that way. Let's go to binomial PDF, 5 trials, 0.54, x value 4, and we paste, and we enter, and that gives me 0.19. And then I'm going to put plus, and then open up a second binomial PDF. And this time I have 5 trials, 0.54, but 5 successes. And when I add both of them up, I get my 0.24 that we were supposed to get. So is everyone following on that same page with that problem now?
Can you say that one more time?
Yes. Binomial PDF, 5 trials, 0.54 with 4 successes. And then you click plus to add a binomial PDF, 5 trials, 0.54 with 5 successes. Then you add the probability of 4 and the probability of 5, and that's all that could be.
So the answer is the 0.24.
Yes. So, one last minute on this one. Did anyone not get 0.24 yet? Good sign in. And then we'll call that there. All right. So here, it does say support your answer. So it's not enough to just give them binomial PDF. You have to explain why you're able to use one in the first place. You want to explain your 4 requirements for the binomial PDF. That's the support for your answer. So it's like half the points come from your requirements saying I can even do this in the first place. And then the other half comes from here's my probability. So that support your, if it didn't say support your answer, you could get away with just giving them what we said. But they're going to say anything, support, explain, justify, which I guarantee you're going to see that a few times this test. Make sure if it's a normal distribution or if it's any distribution, you explain how you know and the requirements that needed to be taken first. If it's like a t distribution, you have to say, oh, look, we could approximate it normal because n is greater than 30. So you're going to have to use these requirements. I'd say have the requirements handy. So open note test. Make sure the requirements for each type of distribution is something that you have right in front of you, because you will be required to support at least one of the distributions, whichever one it might be. Here, binomial, you might see another one that was not normal, but the sampling distribution becomes normal. Am I losing anyone yet, or are you guys kind of okay with what we were just talking about? Okay. So that's good. So I'd say instead of, well, we can do one more because we didn't do one like this yet. So let's go ahead and try to get this out of the way too. Unless you guys had more questions with that one and wanted to stick here. So any ideas? All right, let's go on. All right, here, tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that kochia plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected kochia plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected kochia plants were resistant. Do the data provide convincing statistical evidence at the level alpha 0.05 that there has been an increase in the proportion of all coachia plants that are resistant to glyphosate. So here is where what you kind of were learning in the past couple of months of statistics comes back. So hopefully it's a little bit more fresh in your minds. But what are we dealing with here? First question, proportion or means?
Proportion.
Second question, do we have one sample comparing to a
Two
population?
samples.
So we have a 2 sample proportion. A 2 sample proportion. This we can turn proportions into basically something that we could do a z-table and standardize it and turn it into normal. So let me go pull up some of the formulas that we're going to need there. Okay, 2 sample proportion. So here's the standard deviation for proportion, and we're going to need that. So what we need to do is once we identified the test, 2 sample proportion, we can do a 2 sample z-test, or 2 proportion z-test, which means 2 sample z-test for proportions. So click stat on your calculators and scroll to tests. Everyone open up a 2 proportion z-test. Here they kind of messed with us because our calculators want how many people out of your first sample and how many people out of your second sample. So let's find what those percentages are. If I got 19.7% of 61.197 times 61, I got 12. So our first sample, we have n equals 61. And then when we find the proportion, it was slightly different, 12.017, but it can't be different than that. So we know it's exactly 12. You can't have a proportion of a person or a proportion of a plant. That doesn't work. So N1, X1. And then we have to find N2, which is 52. X2, 38.5% of 52. That's 20 people. So X2 is 20. So now let's go back to our 2 proportion z-test. Now X1, 12. N1, 61. X2, 20. N2, 52. And now it's saying, does the data provide convincing statistical evidence at alpha 0.05 that there has been an increase in the proportion? So our null hypothesis is that proportion 1 equals proportion 2. The alternative could be greater than, less than, or two-tailed, but in this case, they think that there has been an increase in the proportion of plants. So they are claiming P2 is greater than P1. Now that's important because that last thing we have to put on our test, P1, and it says ... less than P2. That's the test we're going to deal with. And then you click calculate. What it gives you is the z-score, how many standard deviations away those are from each other. And then it tells us the probability. What's the probability you guys see there?
I see 0.015355685886.
Okay, perfect. 0.0136. Now, So with this two proportion z-test, we made sure we picked the right direction. We get, if the null were true, these samples, we'd get samples this far apart that much of the time. So what does that say about the null at the level alpha equals 0.05?
That we can reject the null hypothesis.
Exactly. So since P is less than alpha, so since P 0.016 is less than alpha, which means it's really unlikely that this happened if the null were true, we don't think the null is true anymore. Reject the null, and we can't end there. That's not going to get our points. Always contextually, we can reject the null. So meaning, how do we interpret that? What is the final conclusion they want us to state?
We want to state that pretty much the Koichi plants are more resistant to glyphosate, and you would say that we have convincing evidence to conclude that the Koichi plants are more resistant based on the evidence at which the null hypothesis is true 0.0136% of the time. Or is that
Close, and you were pretty good to the end. I'd say, yes, it does provide convincing statistical evidence at the level alpha point.
okay?
That there, yeah. So I'd rather you say that than
Okay.
So at alpha point, that yes, there has been an increase.
Okay.
And then finish up the whole sentence, increase in proportion, and don't stop till you get all the way to the end. Oh, so that I think it's a good place to end. It's where we finished our time right there. But any last questions on this problem? And how?
So we have to pretty much state that this is all possible. For example, we have to state that it's the 10% condition, the random sample condition where we can say that the distributions are independent. Do you have to state conditions is what I'm saying.
Let me see, because they did not say support or justify. Maybe we're allowed to just do it, but I'd always recommend, if you know what the requirements are, really quickly. So let's see, let me double check how they scored this problem though. So just to answer your question a little bit better. Let me see their scoring guidelines. Yes, you have to explain them. They're going to take away, like, this question is worth a lot of points, but they will take away a small amount if that wasn't there. So yes. So let's kind of keep that rule of thumb. Anytime you're going to do a test, explain the requirements were met before you even bother. So here we should have said, can we do this test? And then we should have said, yes, n times p is greater than 10. N times 1 minus p is greater than 10. So we have to use those conditions for the z test statistic for proportions. So bring those up. And then you also wanted to do the populations are extremely large, so we're not sampling more than 5% of the total population. So those would be the two requirements there. The NP must be greater than 10, and 1 minus p greater than 10, and n must be less than 0.05 of the total population size. Questions there? Yeah, so that was a good one. So again, please do make sure whenever you do take the test to have that requirements sheet there. It will be points, and it's something that is easy to not put. We could definitely have answered this question very thoroughly without it, but we will not be getting full points without it. So I'm glad you brought that up. Other than that, nice job today. You guys kept up very well, and I hope that helped. And I would be available for one-on-one lessons anytime before the exam. And I'd like to offer anyone that was here today, my normal rates online are 100 an hour, but I'd like to offer you guys 70 an hour. So if anyone does decide to work with me later, send me a message and get you a discounted rate I didn't offer to anyone else. But other than that, thanks again for joining me. And I hope you guys have a good one. And if I don't see you again, best of luck on your exams.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Very welcome. Have a good one.